Solutions to a differential equation.
All right, class. So today we want to look at solutions to a differential equation. Solutions to a differential equation. And with this one, I'm only going to tackle two particular questions that will give you a general idea on how to find the solutions to a differential equation or to prove whether a particular equation is a solution to a differential equation. So what I want to know under this very concept is that most questions will give you the solution and they will ask you to prove or show that this particular solution is a solution or this particular equation is a solution to this differential equation. So that is what I want to look over here. So there are two questions I would like to do. And the first question, it says that we should show that y is equal to 1 over x squared minus 1 is a solution to the differential equation. Is a solution to this differential equation y prime plus 2x y squared is equal to 0. All right, please take note that let me just give you this tip over here. Take note that anytime you have y prime is the same as what? The y dx. If you have y prime prime is the same as what? The square y over what? The x square. If you have y double 3 and you have y 4, this is what? The cube y over what? The x cube. And this will give what? 4y over what? The x exponent 4. So this is the higher derivative. So we just use the y prime simple to what? Identify it. So you just put this in your head. So that in other videos when you are using these very ones, you will not be confused. Alright, so now this equation can still be written as what? The y over the x plus 2xy squared is equal to 0. So now, to know that, the trick over here is that to know that this is actually an actual solution for this, you have to put this in this nature. And when this comes into this nature, or you put this function here into this, then you should have an answer of what? Of 0. So if you put this function here into this, then you should give what? You should get 0. If you get 0, that means this particular y is a solution to what? This differential equation. So now what happens is that you realize that what is our y? So our solution, our y here is 1 over what? S squared minus 1. Alright, so now we need what? From the equation, from the differential equation, we need what? Y prime, and we need what? Y squared. So from the differential equation, we need y prime and we need y squared from this y, so that we can place it into the differential equation and see whether we will get what? 0. Alright, so now, how do you get, so we can easily get our y squared, which is the same as what? 1 over x squared minus 1 all squared. So this is our y squared. Now how do you get our y prime? So we have to differentiate. Our y prime is simply differentiating the y. So we are taking the derivative with respect to x of what? Of the y, which is the same as what? Our y prime. And when you do that, the formula to do that, because this is a quotient, it is what? V du on the x minus u the v on the x, all divided by what? V squared. And this formula is called the quotient rule. This formula is called the quotient rule. And you should know it because under differential equation, nobody is going to teach you the quotient rule and the product rule. So we believe that that should already be in your head. Alright, so now you should know it, but I'm taking, for the sake of the video, I'm taking time to go through it so that you can understand it again. So now, we take it as what? Y is equal to what? U on what? On V. So from this, you can say U is equal to what? The 1. And our V is equal to what? Our x squared minus 1. So now from here, if you take the u over the x, you get what? 0. If you differentiate the constant, you get 0. And if you differentiate the v on the x, you get what? 2x minus 0. So which is the same as what? 2x. Alright. So now since we are having this, then we can easily get on with it. And we have that, that means our y prime, simple now, becomes, that is our v, which is x squared minus 1 times what? The u on the x, which is 0, minus our u, which is 1, times our v on the x, which is 2x, all divided by our v. And our v was what? X squared. Sorry, all divided by our v squared. So that will give me x squared minus 1 all squared. So now when you simplify this, you get minus 2x divided by x squared minus 1 all what? All squared. So that is what? Our y prime. So if this is then our y prime, then we've gotten our y prime and our y squared. So we can put it into the equation. So what is the equation? Y plus 2xy squared should what? Should give us 0. And if you give us 0, that means this particular equation here is a solution to this differential equation. Okay, so now what is our y prime here? Putting it in it, we have minus 2x all divided by x squared minus 1 all squared plus 2x into bracket. What is our y squared? That is 1 divided by x squared minus 1 all what? All squared. So now, when you do this, what are we getting? When you do this, what are we getting? So now we get minus 2x all divided by x squared minus 1 all squared plus this one will come here, so the same as 1 squared, which is 1, and this one also get the square. So you get what? Plus 2x all divided by what? X minus 1 all squared. So you realize that this is the negative part of what? Of this term over here. So they will cancel out and they will give what? 0. So since they are giving you the answer 0, then we can say that y, which is equal to 1 over what? X squared minus 1 is an actual solution of the differential what? Equation. It's an actual solution of the differential equation. All right, let's take the second example. And I believe that the second example, you should have a very good understanding of how we know the differential equation. All right, and the second example says that, from the second example, it says that we should show that y, which is equal to the exponent of negative x plus sine x is a solution to this differential equation. We should show that this is a solution to this differential equation, which is the square y over the x squared plus y is equal to 2a exponent minus x. So now this is it. We should show that that particular thing is a solution to this differential equation. Please, I've given you the simple. I'd like you to pause the video and try so that you can come back and we do it together. So now, what happens over here is that as we did over here, you consider the left-hand side. You operate on the left-hand side with the solution. So if you get it, then if you get the same thing as this, then we can say, right, that particular equation over there is a differential equation. It's a solution to the differential equation. All right, so now, this you can also be written as what? Y prime prime plus y, which is equal to 2e minus x. So now from the differential equation, from the equation plus sine x, what do we need? Now we need what? Y prime prime. And 2, we need what? We need y. But we already have y here as this. So we only need y prime prime so that we can fix it into what? Into the differential equation to see whether we get the 2 exponent negative x. Okay. So now, to get y prime prime, we have to first do the first derivative, which is what? Y prime, or the same as what? The y on the x. And it's equal to, now anytime you have an exponent, you find the derivative of an exponent. Anytime you find the derivative of an exponent, if you have something like a, the derivative of that becomes what? A e exponent a. A exponent a. That is how the derivative works for an exponential function, for an exponent function. Alright. So now that will give you what? Negative 1 e exponent what? Negative x. Because you find the derivative of what? The exponent over there. And you find the derivative here, it will give you a negative 1. So you just bring that one forward and you go on. Plus, anytime you find the derivative of sine x, so the derivative of sine x over the x is always equal to what? Cos x. It's something you should know from your secondary school. So this will give you plus what? Cos x. Alright. So now you have to go through again and find our y prime prime because that is what we did, which is what? The square y what? The x squared. Now, upon doing our y prime prime, when you differentiate negative e exponent negative x, it is what? Negative 1 times negative 1 over here, e exponent negative x. So the negative and negative will give you positive. So when you do that, you get what? Positive exponent e of negative x. And anytime you differentiate cos x with respect to x, you get negative what? Sine of x. Anytime you differentiate cos x with respect to x, you are getting negative sine of x. So now when you do this, you get e minus what? Sine of what? Of x. Alright. So now since you get this, you can now put this into the equation. Now what is the equation? Y prime prime plus y. That is the equation. So now what is our y prime prime? That is e of x negative x minus sine x plus what is our y? Our y is this plus e of minus x plus what? Sine x. So now when you write this equation down, what are you seeing? You realize that this is minus sine x, this plus sine x. So this can take this away. So you get this and this, which will give what? 2e of what? Negative sine x. And now this is equal to the solution over here. The same answer you're giving here, 2e minus sine x. So since it's equal to, then we can say that y, which is equal to e of minus sine x plus sine x, is an actual solution of the differential solution equation. It's an actual solution of this differential equation. Thank you very much for joining this class.